Greetings, this is Artie from Artifact Electronics. In this episode we're going to be looking at an EICO Oscilloscope Model 425, and I've already peeked around the inside of it a little bit. The build sticker says November 21st, 1952. Now the way I got this was, some of you may remember I did an episode on a B&K precision tube tester a while back, and while I was picking that up from a local seller, I was walking to the car when he came running after me and said, "Hey, I got something else in the garage you might be interested in." And he showed me the scope. Now this scope didn't look anything like this. It was covered in rust, so the gray case was mostly a brownish color, and the front part looked dark gray because of dust on it. So I really didn't want to have to deal with this thing. But the seller was quite insistent, and but I politely declined, and he seemed to be okay with it. But then he turned around and said, "You know what? Just take it with you. I don't know what to do with this anyway." Well, I thanked him for the kindness and brought it back home. Now, from my description, this obviously looks a little bit different, but I've spent some time cleaning it up. What I did was I took it outside, I removed the gray case, and using dishwashing soap and a fine abrasive sponge, I did about 3 passes over it, cleaned it up, hosed it off, and most of the surface rust actually disappeared. And so I let it dry in the sun, and then I got to work on the front panel. Notice I had not plugged it in or turned it on at that point, but the front panel revealed this really pleasant medium blue color, and all in all it's a very interesting looking scope. There still is some rust on it. I mean, you can see at the edges that some of the rust is still there, and that wouldn't come off, and there's still some spots here and there, but it actually cleaned up pretty nicely. So we should probably take it apart and have a look inside to look for any obvious problems, and then maybe give it a try and turn it on. Here's the inside of it, and the inside of it actually wasn't that dirty. I guess the case did its job. Now at first look, if you remember the episode I did on the Heathkit 012, the geometry of the chassis looks very similar to what the Heathkit looks like. But of course this came, several years before the Heathkit, so I don't know, but I guess this was the common geometry they used to build oscilloscope chassis. Now this has 3 different types of tubes in it. It has a pair of 5Y3 rectifiers over here for the power supply. And then it has a pair of 6J5s, one here and one there, and a set of 3 6SN7s. Here, here, and here, hidden, and electrolytic capacitor over here, and oh, I see that the stuff behind is showing through. Let me put something in front of it so there's no confusion about that being in modern capacitors being in here. There are these 2 nasty oil-filled capacitors here and here. I mean, this part of the chassis is almost perfectly symmetrical, except for this capacitor back here. And of course we have a Sylvania tube in here, and there's not even a way to adjust trace rotation properly here. I think what you got to do is loosen the plug. The ring that holds the plug in place probably needs to be loosened so you can rotate the tube and to get to straighten out your trace if that is required. And of course, the other side, a lot of the stuff is, there's no PC boards in here. A lot of the stuff is mounted directly on the controls over here. And again, the transformer's in the same place as it was on the Heath kit. And other than that, I think that's pretty much all she wrote. Now let me see if I can get the build sticker I referred to, which actually isn't a build sticker, but a build stamp, into the picture without it being obscured by the shadow of the CRT. And lo and behold, you can see that this was tested on November 21st, 1952 by EICO in Brooklyn, New York. It's got a signature or the initials of who tested this on here. And I did some reading on it. There's not a whole lot of information on this scope, but I think this was also offered as a kit. But because of the sticker, we can safely assume that this particular unit was factory built. So here's a look at the transmission and exhaust system. The underneath of the scope. Really not much to say. It's got a pest of paper capacitors in here. The both legs of the AC line are fused. And other than that, we have the one electrolytic multi-can cap over here. I'm going to try to measure those, but that's going to be difficult because it's got a whole it's a whole network of dropping resistors connecting the positive sides of all the caps together. So it's not going to give me very accurate readings on those. But let's go ahead and see what it says. So starting, let's start with the top cap in here. And in circuit leaky and a really high ESR. Still has a high ESR, but it came up with a value. It's supposed to be 10 mics, which is good. And finally, that one's supposed to be 20, but the ESR is still high, which is not that surprising considering the scope is coming up on its 65th birthday, if we go by the build date. What I want to do next is, I'm not going to remove this, and I know some of you are screaming, I need to go in and replace all of these capacitors before I dare to turn on the power. But my intent at this point is not, at this point in time, to restore this, but rather see if it powers up. And in order to prevent anything, or do the best I can so things don't blow up, I'm going to go through and measure all of the capacitors. Like I did the electrolytics now, the others are too low in value to be measured with the tester. So I'm just going to use a multimeter and see and check them for shorts, and also check them for value. And other than that, I already looked under here that there doesn't seem to be anything, any of the resistors looking bad. I'm going to go through and spot check some of the resistors too. And let's see, what else do I need to do? That's about it. We got the oil-filled caps here, here, and here. And maybe that would be interesting to see if they, what kind of a value they show us. And for that, these two oil-filled ones are 0.1s here and here. And this one is oh, this one's actually a 1 microfarad, so the tester may actually tell us something useful about it. And yes, I did discharge everything before going in here. So actually that big 0.1, 1 microfarad, that looks good. It looks really good. Yeah, I know, some of you are cringing, how can I possibly turn this on, or consider turning this on with a cap that old, but here's what the meter says. And the other two, as I said, were 0.1s. This isn't, I don't think this meter is going to be able to tell me anything, but let's try that too. It thinks that those are 0.54, the bottom one, and the top one is a 0.56, and the ESR seems to be good too. So let's see, I thought I read these and they said 0.1 on them, and no, they are actually 0.5. Those are 0.5 microfarads. So I guess those two read good too. But I will go through and measure all of the paper caps for shorts, pretty much all of the caps for shorts. And if I see any strange looking resistors, I will test those too. This resistor does look kind of nasty. Not resistor, the capacitor. Let's see if we can get a better look at him. I don't know if you can see that, but it looks like whatever is the outer covering is beginning to bubble off it, and but you know, upward and onward. I will go. I'll do a quick test of component test off camera, and then we'll get to the big moment. Another thing I wanted to point out real quick was it's actually really clean under the hood. I mean, here's a transformer, and even though in the video it may show a little bit of a brownish hue over here, that's not really true. There is no rust whatsoever on the laminates on this thing, and considering what the outside looked like, I am really surprised that none of that made its way inside and attacked anything here. Also, you know, looking at the chassis, and everything looks nice and clean. If it weren't for the paper capacitors, I probably wouldn't have hesitated to just turn this thing on, but yeah, I guess I'd better go ahead and do some checking on this stuff, because I don't want this guy to go up in smoke. I am developing some fondness for it now, and I think I need to protect it. So I spent a good half hour testing all of the caps, spot checking some of the resistors, and everything was good. Of course, the most important part was that I also checked all of the tubes in here, and the seller had told me that all of the tubes were good in it. And so what I did was I didn't test them with the tube tester that I got from him, but rather my older EICO tester, just in case there was some weirdness there. I actually tested them with both tube testers, and the tubes were all good, and they weren't weak or anything. They were all showing medium deflection. So I think this thing probably didn't spend a lot of time doing honest work in its life, but or it's seen very low usage, I would say. But here is the moment of truth. It's plugged in, and no magic smoke, no regular smoke. I can hear the tubes warming up. and I can feel them warming up. So let's turn some dials here. So this is the intensity. There's a trace. And we can even, well, I got to go all the way to the right to focus it, and actually turn the intensity back a little bit to get a better focus on it. But let's see if I can turn this light off back here. And if that, no, that light actually doesn't do anything, so, but I'll leave it off. Yes, there are reflections up here. That's not in the tube. But yeah, the trace isn't anything to write home about. But hey, it's there. And oh, that tube actually. So if you look, let's see if I can show you that. If you look at the end of the tube, as I am turning the tube, the end stays stationary and the front part of the tube turns. Now that can't be good, but I guess I can straighten out the fix the trace rotation on it by simply what I'll do is I will straighten it out, let it warm up, and let it sit for a while, and then put some hot glue on the junction of the glass and the tube base itself back here, and that'll be my that way I'll fix the trace rotation. So the trace is dancing a little bit. I mean, I can see it dancing, so it's probably doing 60 or 120 hertz there. And yes, it's going to need new caps. But as we can see, so let's try the other controls, the up-down adjustment. And that works, even though it's kind of laggy, which I'll also blame on the capacitors. Horizontal position also works, but is also kind of laggy. And so what else do we have? Okay, now to test the rest, we're going to need to put a signal in there, and the scope conveniently provides us with, let's see, a 60 hertz test signal. Now, these aren't even banana plugs. These are just the screw-on test points here. So if I were to use this in any serious manner, I think the first thing I need to do is replace all of these connection points with actual banana plugs. But let's see. Let me get a clip here and connect the 60 hertz test output to the vertical input. And all right. So now, did I connect that right? It's almost acting like I connected it to ground. No, it does look right. Okay, so that's the coarse frequency, and for the vertical, oh, I need to turn down the gain, and actually turn down the gain a lot, bring the trace up. The gain is still too high. and we get something that is beginning to approximately look like a sine wave on here. Let's see, can we get any more of them to show up? And so here we can start seeing the sine wave. I changed the horizontal gain and the position a little bit and bring it up a little more, and let's see if by adjusting the frequency over here we can get something, and yes we can. Now you can see, okay, let's see if I can get rid of this glare a little bit if I raise it like this. Yeah, that's not much better. Well, actually it is. So let me find something to prop this up with. And there you go. So we got a somewhat stable display. If I turn the intensity down, the focus gets better on it. And by increasing the horizontal gain, we actually get a pretty passable sine wave. I mean, it is distorted. It is clipping on the top and bottom here, and I'm not sure if I can fix that. The clipping stays. I mean, especially if you look at this part over here, as I'm changing the vertical gain, it is still clipping there, but I guess you can go to this part and get a passable sine wave display on it. Now, one other thing I didn't show you, it does come with this overlay, the scale overlay here, which is just a piece of plastic, and the surroundings here are felt. So I think this is made to be held in place by friction, but so then this is what it looks like. So I guess it works. Nothing has blown up yet. I smell no smoke. I don't see anything stressing or melting in here. So let's see if we can actually put an external signal in, a different waveform, and let's see if that shows up. Here we have a 10 kHz 1 volt sine wave coming out of the function generator, and let's see if we can actually see this. So let's give it a little bit more gain, not position, but gain, and see if we can get this thing to sync. And there's a 10K sine wave. So the distortion we saw when I used the internal generator is gone on the sine wave. The peaks and troughs are pretty rounded. I'm not exactly sure if this scale overlay is doing us any good. What do you think? Let's see. It's okay actually. And well, there's our sine wave. And when I crank the gain, it loses sync, I think, is what's happening here. Let me see. Yeah. So here we get our sine wave. Let's get a few more cycles in here. And, oh, I guess I should shade it like this, that way you can see it better. But let's switch over to a square. And as you can see, it doesn't handle the square really well. Probably due to the input capacitors. You can't set this to DC. And the triangle kind of looks like the sine. So let's say we drop down the frequency to 5K. Let's try. See if we can make it look more like a triangle. And well, yeah, it's beginning to look more like a triangle here. Let's go look at the square again. That's pretty horrible. Yeah, it's not really showing the square. And drop the frequency down to 1K. And now, let's see, let me lean over here. Yeah, now we can actually see square waves coming out of this. And now we got good looking triangles on here too. Let's see if I can get some more in the picture. Yeah, at low frequencies it looks, I mean at 1K hertz it does seem to work well. And yeah, another thing, you saw the trace kind of being unstable. I have cleaned all of the pots by the usual way of spraying contact cleaner in them and working them back and forth rigorously. But I think this pretty much shows us that this needs a whole new set of capacitors in order to be stable. I mean, there's no damage done, nothing is malfunctioning, but I'm pretty sure that the results we're seeing here are caused by the age of the capacitors, and that things would improve quite a lot if we actually replace the capacitors. Finally, I'll try to set it up for XY operation, and so I'm running the internal signal, which is the 60 Hertz test signal, into the vertical input, and the output from the function generator into ground and into the horizontal input. And so we got to switch the horizontal input to external, and since the test signal is at 60 Hertz, let me turn down the function generator to the neighborhood of 60 Hertz, and see how it does on XY. Okay, so let's adjust vertical amplification or gain, and then the horizontal gain, and see, I can't focus it. I mean, I have to turn the intensity down, and since this 60 Hertz is derived from the line, and the HP function generator is pretty accurate. Let's see, what is it doing now? It's showing us. So there's, as we can see, very slight difference, but let me crank the frequency on the HP up a little bit. And yeah, we're not getting a circle out of it, but let's go to that's 75 Hertz input, and if we go to double at 120, then we see this. So XY operation seems to work, but the linearity of the traces is nothing to write home about. So again, sounding like a broken record, and verifying what some of you may think. It does need a full set of capacitors, and I do need to go in and measure the high voltages to see why the focus has to be cranked up all the way and the intensity brought down. Because if I bring the focus down, yeah, it just completely gets blurry, but then when it's cranked all the way, you get a semblance of a focus trace on this. So this is basically out of the box. I cleaned things up, I tested things, I haven't replaced anything, and this is how it works out of the box. And maybe in the future, if I feel so inclined or run out of projects to do, I may go in and recap this whole thing and give you another look at it. But for now, this is how she works out of the box. Okay, put her back together again. I've also, you saw this at the beginning, I already had replaced the screws because the originals were in really bad shape. And and also it looks like I figured out how to get rid of the glare, because this scale overlay here did wonders for reflecting pretty much everything. I think even if I had a black hole here, it would reflect that. But anyway, let's finally see this guy boot up with a signal applied to it. And see if I broke anything while putting the case back on. And I guess I didn't break anything. There's a signal. So yeah, final words are it needs caps. As simple as that. But other than that, it's a pretty cool 65-year-old scope, and it pretty much this far took $0 in parts replacement costs. Means it was built, it's a pretty good quality scope. Anyway, enough fun for today. Thanks for watching, and I hope you enjoyed it. Give me a thumbs up if either you liked it or you just want to keep me motivated, and make sure to subscribe. See you next time.